Today, let us start Vicker's hardness test. Let us start Vicker's hardness test today. As I've already discussed in the last class, in earlier classes, this type of hardness testing methods, but we are repeating the same as we have done time and space in mind. Now, these are the different important standard tests which is being conducted throughout the world to check different type of properties, to know and find out different properties which is usable for subsequent design and manufacturing of certain machine members. So in order to do the same, we are supposed to know the hardness of a particular items. How much hardness it is, and how much hardness it is required to be. We have to tally it to make it a perfect material or a perfect machine member or a perfect machining. Now, in order to know it, we have to supposed to know the hardness to the accurate level. Now, in order to know the hardness, we are supposed to go through different type of hardness testing machine like Venus hardness testing, Vicker's hardness testing, as well as Rockwell hardness testing. Actually, what you mean by hardness, I have discussed a number of times. It is the ability of the material, ability of the machine member, or ability of the item to resist indentation or indent or any sort of scratching, any sort of wear out over its surface. Okay. Yes, just have answered your comments. Now, the Vickers test is one of the tests which is supposed to be thought of as the most accurate test and most what I will say, and the most accurate as well as most highest the test which can cover the hardest material, hardness of the hardest material. It is possible. Just 1 second, please. Yeah. Now, let us discuss the different aspects of the Vickers hardness test. Now, this test consists of indenting or piercing the test material with a diamond indenter in the form of a right pyramid with a square base and an angle of 136 degree between the opposite faces, subjected to a load of 1 to 100 kg. But what this means, you have an indenter, with that is essentially single indenter. This is essentially made of diamonds, which is having a looks, it's like a prism with like a right pyramid with a square base, and it's include an angle 136 degrees between the opposite faces of the pyramid, and it can be subject to the load as high as 100 kg. But in our machines, we are supposed to have the load capacity of 100 kg, 550 kg. The full load is suddenly applied as known and set period of set 10 to 15 seconds. It can be set on the machine as per your requirement and as per your own thinking and own idea. The two diagonal of the indentation left in the surface of the material after removal the tools are measured using a microscope and their average is calculated. What we got the impression is generally in the case of a rectangle or you can say a rhombus even, which is not that accurately shaped like a rectangle, clear-cut rectangular square or rhombus, but near to it. And we are supposed to calculate the diagonals, both length of the diagonals and take the average of the diagonals, and then tally with this side with the Vickers hardness chart to know the Vickers hardness, required Vickers hardness. The area of the sloping surface of the indentation is then calculated. This Vickers hardness obviously obtained by dividing the kg load by the square millimeter area of the indentation. All the hardness numbers which we have found from Vickers, from Brinell, from Vickers, the Rockwell, we are supposed to have the hardness, the load applied for the indentation divided by the cross-section area of the indent produced. That is this ratio gives us, or the value of this ratio gives us the required hardness in quantity. If F is loaded in kg and D is the diameter, arithmetic mean of the diagonals D1 and D2, then HV will be Vickers hardness L divided by D square. When the main diagonal of the hardness had been determined that Vicker hardness may be calculated by the formula, but it is more convenient to use conversion tables because conversion table does exactly the same thing, measuring the hardness by getting the applied load divided by the cross-sectional area of the indentation. Means, say a Vicker's hardness of 1800 Vickers means a Vicker's hardness of 100, which is obtained by using 10 kg force. Several different loading settings have practically identical hardness numbers, are uniform materials, which is better than the arbitrary changing of scales with other hardness testing methods. The advantage of Vicker's hardness test as the extreme accurate readings can be obtained, or that extremely accurate readings can be obtained. And just one type of indicator is used for all type of metals and surface treatments. So it is most accurate type of hardness is required because measurement can be matched with the required hardness up to 3 degrees of freedom. I mean, 3 degrees. I mean, up to the 3 digits, and the and several different loads is practically identical standard number. And although the thoroughly adaptable and very precise of testing of soft test and hard test of material, under varying load, Vicker's machine is floor standing unit that is more expensive than the Brinell and Hartel machine. That is now a trend towards reporting Vicker's hardness in SI units, MP or GA, particularly in academic papers. Unfortunately, this can cause confusion. Vicker's hardness value should be expressed as a number only without the units of kg per square millimeter, etc. Rigorous application of SI is a problem. Now, most Vicker's hardness machine use 1, 2, 5, 10, 50 kg like us, and from maximum 100 kg and tables for calculating the Vicker's hardness. SI should involve reporting forces in newtons compared to 700 HB per 30 ton or HB by 294 Newton, etc., which is practically meaningless and is not the innocent technician. To convert a Vicker's hardness number, the force applied needs convert from Newton to kg to Newton, and the area needs converting from square millimeter to m cube to keep result in pascals. So these are the not that important thing, what will be the units in SI or something, but main thing is that any hardness number in Vicker's, Brinell, and Rockwell is generally the applied force divided by the area of the cross-section area, but it is given by the number only and given in the same of appropriate chart of different Brinell as well as Vicker's and as well for Rockwell's on the dial gauge, which gives us a number which telling us the required hardness of the constant test pieces. Now, you should. Now, let us have this, our Vicker's hardness testing machines in more details. So, our model is defined as, our Vicker's machine is defined as VM50. It is a mechanized hardness tester with automatic loading and unloading device. A regular pyramid with square base and a smooth of regular base pyramid is a regular pyramid with square base and smooth point of made of diamond is pressed into the metal is to be tested under certain load. What I've told you, just we have a pyramid. We have a pyramid with square base and with included angle 135 degrees in between the top apex of between the mid planes meeting at the top apex, and this can be impression thus produced is projected in a focusing front scheme, which will give a projected magnified reading of the indentation produced on the surface, and by means of an optical mirror management, which will give us a correct shape of the indent which we have produced. Now we have to measure the diagonals of the indent by means of the scale given in the measurement people in the Vicker's machine for the measurement of this indent, and we are supposed to know the diagonal length of the impression, which is essentially looks like a rectangle or a rhombus or maximum a square. May not be accurately defined, but close to it, and we have to calculate the diameter and in the diagonal of both this rectangle or square or the square shaped items, and we have to take the average of the diagonal. And as per this side dimension of this diagonal, and it can be measured up to 3 digits of accuracy, will be compared in the Vicker's chart to know the accurately the Vicker's hardness number of a constant test piece. This method can be applied simply hard and thin specimens, as well as determining the hardness of case hardened steel. The body of the machine now is closed by cover, and the machine inside the cover thus protected foreign dust and foreign particles. The basic system is one of the weight and levers. The load is applied by standardized weight through a lever having an anti-friction bearing fulcrums and 9-phase floating plunger system. The duration of the test is controlled by an adjustable electronic timer, and all 9 phases are hardened, ground, and lapped. Hardened, ground, lapped, and inspected with high precision optical instrument, thus ensuring accurate test. Now, test rate could be as high as 50 kg, but not more than that. The magnification of the optical measurement devices will be around 70 times. The maximum test height will be 230 millimeter or 23 centimeter. Scale risk count will be 0.001 millimeter, and dowel time means holding time of the indenter into the wart for indentation is around 0.3 plus minus 2 seconds adjustable. Now, dowel time means the amount of holding. You can engage the machine, make the doweling of the indenter to the mark, remains steady. The dowel remains there for a few seconds, then withdraw the indent and then return and return to the original position and measure the impression. So first, indenter should go to the requisite position on the wart, then go down and make the indent and keep itself engaged in the wart for a few seconds around, giving us the dowel period as around 0.3 plus minus 2 seconds, then withdraw and go back to their original parent level. And then all the optical measuring system will operate and take the measurement of the impression and tally it with the middle hardness task. Having local hardness, Vicker's hardness machine. So what we have, we don't have much equipment is required for making the test, which the item required is standard test blocks and diamond penetrated, one standard test plus or one diamond penetrated. The choice of the loads is to carry out Vicker's hardness test against load 10, 30, 40, 10, 50, 30, 40, 10, 5 kg. These weights are selected through an indexing weight selection knob from outside. And how much weight you are supposed to select is entirely from your experience in previous experience in measuring the weights of this type of job. An optical device is given for projecting the impression of front skin with 70 into 70 magnification, which is capable to project 1.2 millimeter impression maximum. Micrometer thimble provided on front skin enables to measure diagonal impression with an accuracy of 0.001 millimeter. It is advisable to select the load in relation to the expected hardness range of the metal in such a way that impression produced should not be more nearer 0.5 millimeter across the diagonal as far as possible. So what the optical device is doing is making a magnification of 10:1075, which is capable of project only 1.2 millimeter impression, project a maximum 1.2 millimeter impression or even less. The millimeter thimble provided on the front skin enables to measure diagonal impression and the accuracy of 0.001 meter. There is a millimeter thimble or a micrometer thimble or a micrometer proposed in the front skin, which will, by adjusting, impression can be measured up to 0.001 millimeter accuracy. So select the load relation to expected hardness range of material in such a way the impression produced should be nearer to 0.5 millimeter across the diagonals. So we have to adjust the hardness by increasing or decreasing in such a way the impression should have the diagonal distance around nearest to 0.5 millimeter across the diagonal. Diagonal distance should be around 0.5 millimeter. We should be making the adjustment and we should make the impression happen accordingly. Next, the Bryant-Simms pyramid test. Before the test, the test area of the specimen should be clear of oil, dirt, seeds, and light. So all the test places over the Brilliant Hardness machine table should be free from oil, all sort of dirt, all sort of seals, all sort of scales. Now the test area should be graven. Test area of the test block should be even, crowned, and polished properly. Lower side should be even, and so that the specimen is well set on the support. Lower side we should have properly placed, properly grinded, properly finished to make it perfectly placed on the uniformly placed over the surface so that the load should be applied similarly. Any load of indentation should be applied similarly in the same manner in everywhere of the workpiece. The specimen and depth of hardness should not be less than about 1.5 the diagonal impression. The load ranges are used at 30, 10, 50 kg. Operation of the machine, let us discuss. The following procedure should be adopted. Select the weight according to the hardness of the specimen to be tested by turning the weight selection knob. The possible figure of the knob is displayed on one side of the knob. Respective figure of the knob is displayed on one side of the knob, and you have to move it and match the required load as per according to the arrow given on the machine on the side of the knob itself. Now the place the specimen secure the testing speed. Now turn hand wheel clockwise so that the specimen go up and will get focused on the front screen clearly. At this stage, a gap of 0.2 to 0.2 millimeter expected with the tip of the diamond pyramid and the top face of the specimen. Means it requires around 0.22 millimeter is managed expected with the tip of the diamond and the top face of the specimen. Now the double diamond, how much time this indenter should be getting itself engaged in the work, it can be adjusted by adjusting the double timer for the required duration of the project. Around 0.3 to 2 seconds, it should be the diamond time. Means around 0.3 seconds to 2 seconds should be the period where indenter should be got fixed inside the specimen. Now press the start button. Now push the start button, which is the red button. Keep it pressed till light. There is a green button. Please it pressed till light inside the work remains on the even after release of the work push sparkle. So the process is the loading cycle starts, and actually through a generated motor provided on the digitized scene, the loading, loading, unloading cycle is fully automatic. So if you push the button, repeat press, then the blue light inside the treatment remains even after the release of the push button. Loading cycle start gradually through a geared motor provided with a relief cap. Now the index of the indenter has to be into the next position so that the objective it will be exactly over the indentation. The indentation is projected on the front focusing surface. Measure the diagonal impression in both the axes, find out the mean. So indentation product front surface, measure the diagonal impression of both these axes and then find out the mean. The index the indenter head to the next position so that the objective of the optical should be exactly over this indentation. Now, what do you mean by the indexing the indenter head? The indenter head can be go up and down so that it should optical should be exactly for the inspection and exactly focused where to see the impression. To have the test change the position of the impression where the hardness has to be checked, because verify from the project on the focuser screen that there is the index at the head of the original position, bring back the indicator on the specimen. Repeat the above specimen. Vicker's number. The Vicker's hardness number or the Vicker's hardness number, it determines such a test is the broad per unit area of the impression found in the formula. Then TPH 1.8544 P to the power square, where P load applied to the pyramid and T diameter of the impression in millimeter. Now, as a result, the Vicker's hardness is determined. The special table is from the special test according to the measure of value of G. Vicker's and mineral hardness are expressed in the same unit coincides up to 400. At higher hardness, Vicker's number is larger than the Vicker's mineral hardness. Vicker's hardness is also used for very hard materials and parts of small cross section. Let us go through the Vicker's hardness chart. Now, this is the Vicker's hardness chart as per is the load, constant load here. Here the load given is 1 kg optional, and there is one important thing to show. There is a mean diagonal is given here 0.03, 0.04, etc. and 0.07. And from there is a measurement from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it will be the hardness given in under all these columns. So it will be like this. If the measured diagonal will be say 0.068, we have to find out the hardness of the point here. That is, hardness will be 401 Vicker's hardness, or 0.02, 0.002. So here we have to check this one. That is 45 degree, 45 Vicker's hardness. So the third digit will indicate this point from 0 to 8, and first two digits will be shown in this side. And we have to select the first two digit, and the third digit we are supposed to select it from these columns, and the column with which it is matches will give you the result hardness. Such with this first two digit 0.20, we are finding from this CRS select. The third digit is only 2, so that is matching from the digit 2 here. So you know that the hardness of the special is 85.4 Vicker's hardness. That scale was for indented load of 1 kg. Now we have a scale of for the load. We have a scale, Vicker's scale as a load of equal to 5 kg, and impressions are given accordingly. 0.023 say here. If the third impression is 0.0234, then we have to find the number 4 here, and our Vicker's hardness is equal to 169. But it is a numberless quantity. This is not exactly numberless because it is measured by means of, I think, a lawyer divided by some of his mates and give this thing impression here. Say 0.030 will be 038 will come here 104. This is the hardness equal to 104. Next comes the higher the load, higher stress is supposed to be in green, but it is not really not supposed to do the same. It can be used for harder loads as per your thinking. Here, for a load of 20 kg, this is the area of the impression. It is around 0.24 to 2829 or 0.3, 0.3, 0.36, 306. Say 0.349. 34 is 398, and 328, and we found the impression is 305. Which is given as 304, which is given as the our required Hardness hardness. Next page, it will go for 30 kg. Here, for the same impression, we'll get higher amount of Vicker's hardness. Say 0.27. If it is 270, it will the hardness will be 763. And if it is not 0 but something else, that is 270 divided by 541. That is given as 4. That is 174. So 263 plus 401. That is 741. Next is the 50 kg, which is supposed to be the highest combat phase. Say here, for 0.310, measurement of 0.310, it will be the hardness 965 Vickers. 0.37, say 7, the hardness will be here. It will match here with 0.36625, 652. This is the Vickers hardness which is available for the hardness testing machine. Let us go through.
Here we have our third hardness testing machine, which is known as Vicker's hardness test. It has a workpiece holding devices or carrying devices as shown here, over which the workpiece can be kept, and with the help of the rods shown there, the workpiece can be engaged with the indenter itself. The indenter here is only one indenter is used, one diamond-shaped pyramid which is fixed here at the top, and after the indentation is complete, a magnifying glass is used here, just like this, to check the diameter of the indenter, and it is being focused and measured over the window kept here. Here in the front of the machine, we have one green green switch which will glow when the machine will start, and one dual switch will red when it will glow for so long the indenter engaged with the worksheet itself. The dialing period can be adjusted over a sensor device, a timer device, so up to which 30 seconds can be used maximum for the dialing of the indented dowel position, so that this can be indented itself. We can set the load required as per our experience, which is shown in this device, in this rod, where from 1, 5, 10, 20, 30 and 50 is the maximum load which we can select here, and as per our rule, as per our requirement itself. Here we have our third hardness testing machine, which is known as Vicker's hardness test. It has a workpiece holding devices or carrying devices as shown here, over which the workpiece can be kept, and with the help of the rods shown there, the workpiece can be engaged with the indenter itself. The indenter here is only one indenter is used, one diamond-shaped filament which is fixed here at the top, and after the indentation is complete, a magnifying glass is used here, just like this, to check the diameter of the indenter, and it is being focused and measured over the window kept here. Here in the front of the machine, we have one green switch which will glow when the machine will start, and one dual switch will red when it will glow for so long the indenter engaged with the worksheet itself. The dialing period can be adjusted over a sensor device, a timer device, so up to which 30 seconds can be used maximum for the dialing or the indented dowel position, so that this can be indented itself. We can set the load required as per our experience, which is shown in this device, in this rod, where from 1, 5, 10, 20, 30 and 50 is the maximum load which we can select here, and as per our rule, as per our requirement itself.
Okay. So this is the micro hardness tester with Vickers and loop scales. It has both scales selectable inside the panel, and now I will show you how to operate this machine. This is a digital model with digital measurement. It has inbuilt a rotary encoder for optical measurements and automatic turret. Here you can see the movement of turret. First you have to place specimen on XY table and raise it with operating hand wheel. You have to focus surface of the specimen, and once it is visible on your eyepiece, then you have to press start key. Now we are taking reading on 200 gram load on this standard specimen having hardness of 430 HV 0.2, and load is selected here 0.2. This load is selectable with this rotary load selector knob. So this machine is having 10 gram to 1000 gram load. Here you can see 10 grams, and whatever load you are selecting, it will appear on the screen. So we are selecting 0.2 kg 200 gram load. Now we have to press start key. It will display the test time, dwell time. Now it is unloading. So your hardness impression is done. Now we have to measure it. So first of all, when you are switching on the machine, the display will show you reset 0. So that time you have to set 0 value on your eyepiece. There are 2 lines we are using for measurement. We have to bring those lines together and we have to make it 0. I will do it now. We have to press 0 key. Now